All right, so we're looking at this question here, and it says the curve C has equation y is equal to 4x plus 5 over 4 minus 4x squared. So on part A, find the equations of the asymptotes of C. Okay. All right, so for the asymptotes, we start with the vertical asymptotes, where we equate the denominator to 0. This is more like x squared is equal to 1. So x is equal to plus or minus 1. So the asymptotes are x is equal to minus 1 and x is equal to 1. All right. And then we can see that the degree of the numerator is greater than the degree of the denominator. That automatically means that we have a horizontal asymptote, which is the x-axis, y equals to 0. So these are the asymptotes. X equals to 1, x equals to minus 1, x equals to minus 1, and x equals to 1. And the horizontal asymptote is y is equal to 0. Part B, find the coordinates of any stationary points on C. All right, so let's take down the equation, all right? It's y is equal to 4x plus 5 over 4 minus 4x squared. So dy by dx is 4 minus 4x squared of the derivative with respect to x of 4x plus 5 minus 4x plus 5 of the derivative with respect to x of 4 minus 4x squared. All right, and that's over 4 minus 4x squared all squared. We are going to equate this to 0 because at the stationary point, dy by dx is 0. So basically, we'll be having 4 of 4 minus 4x squared minus, this becomes plus 8x of 4x plus 5 equal to 0, which is 16 minus 16x squared plus 32x squared plus 40x is equal to 0. So that's 16x squared plus 40x plus 16 equal to 0. Then we can divide everything by 4, right? Is 4 the best that we can, or maybe by 8, right?
Yeah.
2x squared plus 5x plus 2 equal to 0. So we can now factorize this. It's
X and 2x.
2x and x,
Yeah.
then 1 and 2. So that
Yep.
if we say x plus this, so it's actually plus and plus. I think this is fine. So 2x plus 1 equal to 0, or x plus 2 equal to 0. And then x, therefore, is minus a half, and x is minus 2. So these are the two x values, right? So I'm going to have this. Okay, so x and y, x is minus a half and minus 2. So when x is a value of minus a half, we have to substitute the value into the equation. All right. Okay, so minus a half, and I store that into x, and we're going to have 4x plus 5, and that's over 4 minus 4x squared. And I'm getting 1. So when y has a value of minus a half, when x is minus a half, y is 1. And then minus 2, store that into x, and we get a quarter. Okay, so therefore, the coordinates are minus a half and 1 and minus 2 and a quarter. Okay, what do you think?
Yep, I got the same answer.
Oh, great. On part C, they say sketch C, stating the coordinates of the intersections with the axes. All right. So let's look at this. We start with the axis. So that's Y. That's X. Okay. That's asymptotes. We have X is equal to plus or minus 1. So let's have those. That's minus 1, and this is 1. Okay. All right. And then the x-axis is an asymptote, so we're good. We've also been given that there are two turning points, minus a half and 1. All right. So say maybe here. All right. And there's also another one at minus 2 1/4. So maybe around here. Okay. All right. What other information do we have? No other information that we have. So we will then have to test, okay, to check for the behavior of the graph about the asymptotes. Let's start with about the asymptote x equals to minus 1. And we can have something like if x has a value of that is slightly less than it, which is minus 1.001. And if x has another value, say, slightly greater, which is minus 0.99, 999 or whatever.
Yep.
How does y behave? Okay. So we start with minus 1.001. And if we substitute it into the original equation is y is equal to 4x plus 5 over 4 minus 4x squared. So if we substitute it into it, we get something very big, minus 1 to 4, very small, okay? Which means that the graph should be coming from somewhere down here. And for minus 0.9999, I'm using my calculator, we get 125 point something. So it's a big value, so it's coming from the top. Then about x equals to 1. We can also have a small little table. This is x and this is y. And we have, say, 0.999 and 1.001. All right. So if we have 0.999 and we substitute it for x, we will be having 1,125, which is a very big value. So for slightly less than 1, it should be coming from here. And for 1.001, we get minus 1125. So slightly greater should be coming from down here. And then you can say as x approaches infinity, we take a value like x is equal to 1,000, just as an example, is a large value. And then you ask yourself, what is y? So when x is equal to 1,000, we get that y will be minus 0.001, which is slightly below the x-axis. So from somewhere here, and then as x approaches negative infinity, you'll be saying that you can take minus 1,000, and for minus 1,000,
Slightly positive.
oh yes, it's slightly positive because 0.00009, y will be 0.00098 8 and something. So it's positive. All right, so the graph should be coming like this because this is a turning point. So we have to show that it's a turning point. Does it show? I don't know.
Very small.
And then this part, it's a turning point as well. So it has to come like this. And then it comes like this. So the graph will be more like this.
Mhm.
They say you should state the coordinates with the x's. All right. So you ask yourself
Yeah.
when x equal to 0, what is y? And when x equals to 0, y is 5 over 4. When x is 0, that's on the y-axis, right? So it has to be
Sorry.
0, 5 over 4 here.
Oh, I see.
And when y is 0, then 4x plus 5 should be equal to 0. So x will be minus 5 over 4. So this point is minus 5 over 4, 0.
I just need to focus on the axis, right? I don't need to focus on the turning points.
Yes.
Okay.
On part D, they say sketch the curve with equation that,
I only did the first part. The second part, I didn't have enough time.
okay, so you did the first part. Okay, let's look at that. So let's place it here. So for the modulus graph, we simply reflect the parts that are above the x-axis, below the x-axis in the x-axis. So we should be having something like this, reflecting something like this. And then we also need to reflect here. So we remove the parts that are below. So the origin here, this is -1, this is 1. And here, this is minus 5 over 4, 0. So this is the modulus graph. All right. And now the question says, and find in exact form the set of values of x for which that 4 of mod 4x plus 5 is greater than 5 of mod that and that and that. All right. So the 4 of mod 4x plus 5 is greater than 5 of mod of 4 minus 4x squared. It can be written 4x plus 5 over 4 minus 4x squared under modulus is greater than 5 over 4, right?
Oh, wait, you can just move the mod? Oh yeah. Okay.
You understand how I rearranged this?
Mm-hmm.
Okay, good. So when it is like this, we have two graphs, the modulus graph and the graph of y is equal to 5 over 4. So the graph of y is equal to 5 over 4 is represented by this line, which has to pass through 5 over 4. So like this. So that's the line, y is equal to 5 over 4. So when we say greater, it means the modulus graph is vertically above. Okay.
Sorry, sir. When we divide two modulus functions, that means the whole equation is a modulus, a mod.
Okay. Sorry, please come again. You said?
So if I move mod 4x plus 5, 4 minus 4x squared to the other side, right?
Mm-hmm.
So if a mod is divided by a mod, that means the whole equation is just a mod.
It means the whole equation is?
A mod is absolute.
Yes.
Oh, okay. I did not know that
We're using the
property.
fact that mod A over mod B is the same as mod of A over B.
Oh, I see. I did not know that.
Okay.
Okay.
All right. So we're going to say here to find the points of intersection, okay? Let's start with the point of intersection, this one, all right, and this one. And what's special about these two is because these are the intersections with the line y is equal to 5 over 4 of the reflected parts of the graph. You see how we reflected this part from the original, and we reflected this line segment as well from the original. So these are
Yeah.
reflected line segments. So this is when the graph for x plus 5 over 4 minus 4x squared intercepts, actually minus because it's reflected, intersects 5 over 4. So it's minus of 4x. If we cross multiply, it's minus 4 of 4x plus 5 is equal to 5 of 4 minus 4x squared. So it's minus 16x minus 20 is equal to 20 minus 20x squared. So it's 20x squared minus 16x minus 40 equal to
40.
0. Right? Divide by 4, that's 5x squared minus 4x minus 8 equal to 0. So 5x squared minus 4x minus 8, is it? Did I do it? Did I do justice? How many times does 4 get into 40?
10.
That's minus 10 equal to 0. So we solve this, okay? We can solve this quadratic. Let's just use the calculator for real quick. All right, so the values are x is equal to 2 plus 3 root 6 over 5, or 2 minus 3 root 6 over 5. All right, so these are the two, okay? I will call this alpha, and I'll call this beta. So this is alpha, and this is beta, okay? Let's also find the intersections, this one and this one. And remember, this line segment is part of the original before modulus, okay, the original function. So it's when the graph 4x plus 5 over 4 minus 4x squared meets 5 over 4. Cross multiply. So that's 4 of 4x plus 5 is equal to 5 of 4 minus 4x squared, which is 16x plus 20 is equal
20.
to 20 minus 20x squared. So that's
20x
20x
squared.
squared plus 16x equal to 0. All right. Let's move it to the right a little bit more. So divide both sides or factor out 4x. We'll be having 5x plus 4. So 4x equal to 0, or 5x plus 4 equal to 0. So x equal to 0, or x is equal to minus 4/5. All right. So let's call this gamma, and this is 0. So for where the graph is, okay, just looking now, coming back to this, is where the modulus graph is greater or vertically above the graph y is equal to 5 over 4. So the modulus graph is greater above. It's above that line here for this line segment, if you can see it. And for here, this other line segment down to here, and for this parts as well.
So it's two inequalities.
Sorry?
So there's two inequalities. I mean, four.
Yes, because we can say here that
more than alpha less than gamma.
Between these two, right?
Yeah. And then more than
So it's
alpha less than,
alpha to gamma, but where x is not equal to -1, right?
yeah.
And between 0, I don't know why we'd call this alpha, but between 0 and beta,
Not
where
equal to
x is
1.
not equal to 1. All right, so how do we write down the solutions? We can say alpha is that. So it's 2 minus 3 root 6 over 5 to minus 4/5 and 0 to beta 2 plus 3 root 6 over 5. And then x is not equal to plus or minus 1. So this becomes the solution.